You don't need Fable 5, not for most of what you do. And as of this week, that actually matters because Fable 5 is leaving your Claude subscription on July the 12th, and every single token will now bill at API rates. So that's $10 per million in, and an astounding $50 per million tokens out. And this isn't just the direction of travel for Claude, it's other providers too. The days of one flat subscription covering everything you throw at it are ending. So in this video, I'm going to show you exactly which tasks are worth Fable 5 money, which ones aren't, and then every setting to turn off that stops your bill from quietly running away from you when you do actually decide to use it. Now, I was totally surprised when I first saw this, but if you open Claude Code and you simply type something like hi, or what color is the sky, like this guy did here on GitHub, that one word or that one sentence could cost you tens of thousands of tokens. You can see here, prompt, hi, 31,000 tokens. Prompt, what color is the sky? 19,000 tokens. And then I can try it on my own repo here. And then if I run /context, I can see exactly the number of tokens that have been used from that simple message that I've just passed in. So message hi, 37,200 tokens. 4% of my context window has been used from that simple message. And you can see the approximate breakdown here. We've got 5K in the system prompt. We've got a bunch of tools, some custom agents, memory files, skills, and previous messages as well. Now, if I'm using Fable, that's around 30 to 40 cents for my first message alone. And then because it caches that data, it's going to be around 3 to 4 cents per query in that conversation when I next have that conversation. So it's adding that additional cost to every single query I make. And obviously, as I add more context, that builds and you're sending more and more, costing yourself more and more. And the important part here is it's not because Claude has written us an essay response, but because of everything that loads before you type in a single character anyway. So you've got the system prompt, the Claude.md files, your memory files, every MCP tool is automatically loaded into here. All of our custom agents, let's say we use GSD, all the skills, we barely have any skills in this repo itself. And with things like the MCP, it's loading in all of the schemas. So all of that is context that's being used up. And then you can type in usage and you can see because we're on Opus 4.8 and not Fable, it's cost around 15 cents in API tokens already. But obviously this is on the subscription plan, but Fable will not be. But it gives us some important indicators here, like in our MCP servers, the Claude in Chrome MCP server is using 45% of the MCP server token usage. So there are methods we can take to actually strip out a lot of this base cost when we're deciding to actually use Fable. So remember the context and usage commands because we'll come back to those at the end and compare afterwards with that same hi message and all of those settings turned off. So Fable 5, as we mentioned, is around $10 per million for input tokens, $50 per million for output tokens. However, with a model as intelligent as Fable, the per token pricing is quite misleading because different models are going to burn different amounts of tokens to finish effectively the same job. So the unit that matters is not cost per token, it's basically cost per finished task. And one team has published their real measurements across 3 workloads, and it kind of tells the story that we're trying to get at here. The first workload, they did just kind of a quick code review, right? So just a 200-line pull request. Now, Fable, for this task, costs around 10 cents, nearly 8 times of what Sonnet cost them. So it's using 3 times the output tokens here. However, the compromise is that it has more thorough reasoning and actually surfaces edge cases that the smaller models often miss. Now, second workload was building a full pricing page in Next.js. Sonnet's version cost around 25 cents, and Fable's version for this cost $4.18, but it was ready to ship. And that's a really important bit to distinguish here because Fable costs 17 times more than Sonnet here, but it also actually finished the task. So Sonnet's output, they had to rework for 2 hours with a human to get it to a point where it was actually ready to ship. So if your time is actually worth $50 an hour, let's say, then Fable 5 is cheaper. The Fable version effectively costs you $4 or $4.20, and the Sonnet version is going to cost you $100 because the opportunity cost is time. And the third workload was the most complex, and this is where the differentiation comes in the most, which is a multi-hour, multi-agent building effectively a CRUD app end to end. Now, Sonnet isn't even in the race here because it loses coherence over sessions that are that long, right? So we're comparing Opus 4.8 and Fable 5. Opus finished at $5.40 with rough edges. Fable finished at $23.70, 450,000 output tokens, but it came with tests and docs, and it was actually merge ready already. So you can kind of look at these patterns, right? The premium for tokens is totally visible. You can see Fable 5 costs the most in all scenarios here. But you've got to ask yourself, are you going to have to rework it if it's not good the first time? And how much is that going to cost you in time or money from labor anyway? Which kind of raises the obvious questions. Which task should we actually be using Fable on then? So there's 3 ways in which I want you to consider using Fable 5. Use it at the stages where output is not token heavy, but you can basically get a lot more leverage. So for example, you might use it in planning and then in code reviews, but don't use it for implementation where output tokens are going to be ridiculously high because you'll be paying that $50 per million output tokens. Or don't use it where you have to scrape huge amounts of data from the web, for example, because you're paying for the amount of data that's absorbed into that context. So pattern 1 is plan on Fable, build on Sonnet. So Claude Code has a built-in alias called Opus Plan. You can type in /model Opus Plan, and it basically means it will plan on Opus, implement on Sonnet. Now, right now, there's no Fable version of that alias. So build it yourself through just a little bit of manual work, and it literally takes 10 seconds, right? So first I'm going to switch model to Fable. Now we can see we're in Fable 5. So I'm going to say plan a pricing Next.js component for my app rankspot.ai. I want to simplify the pricing system that I've currently got. So I want it to be $79 base for 30 AI generated articles that help you rank in SEO. Then I'm actually going to discount pricing for additional brands being watched. And for some context, we basically have 3 plans right now, a starter, a growth, and a premium, but I don't think this pricing is simple enough. We want to basically generate 30 articles that are going to help a business rank for SEO every month, but I want to transform this into basically be the only plan, and we just advise customers to go for that plan. But if you want to actually rank for more brands, then we're going to give you a bulk discount for operating with more brands on top of that. So all we're going to do is basically put it into plan mode using Shift-Tab to cycle and effectively set that off to run. And I've put that in a completely separate work tree so that we can basically create this pricing component and then execute on it using something like Sonnet instead. So plan with Fable, where it needs to think out the actual logistics, the architecture, and then build on Sonnet. The planning is going to take fewer tokens than the execution, and that's why we do it that way around. Now, that used about 38,000 tokens to do the planning, took a couple of minutes, asked me a few questions around edge cases, which is the important part of using something like Fable because it's intelligent enough to actually look through the files and work out what those edge cases might be, and then come up with a complete plan. So here's the stage where we actually manually switch the model. So what we need to do is tell Claude to actually put it inside a plan.md file inside my projects folder, and I'll just say only do that, because if we start to execute, then it will automatically move on to execution inside of Fable 5. So all we're going to do is execute basically by putting it inside a plan.md folder. We're then going to run the model command again and switch back to Sonnet. So we're going to pay Fable rates on the plan. We're going to switch back to Sonnet for the implementation and pay for Sonnet rates on the implementation. So we basically get the intelligence in the plan, and then the execution is done by just this Sonnet model instead. And all we're going to say inside this is execute the plan.md file inside Y directory. There we go. And now it's giving us the option to switch back to Sonnet 5 or Sonnet 6. And all we're going to do is execute the plan inside the project/plan.md folder. I'm going to run that. And that is case 1. Case 2, or pattern 2, is leveraging the fact that Fable is built to be a reviewer. So Fable 5 is a Mythos class model, which, if you remember, was able to find exploits that got it suspended by the US government. So finding what's broken is the thing the model is actually really good at. So we can use it for reviews too, reviews of our code. So we can do this by creating a super simple sub-agent that forces it to use Fable to do specific tasks like any code reviews, for example. We're going to go inside our .claude folder. We're going to make sure we have our agents folder. And then inside that, we'll just create code reviewer.md. So very simple. You just have the reviewer, reviews code changes of bugs, edge cases, and security issues, use after implementation. And we basically specify the model here. We've got a schema validation issue, but Claude assures me that it should be written like this. So it's just an extremely simple agent that Claude will know to automatically invoke when you do specific tasks like code reviews in this case, and we give it access to certain tools too. And importantly, we say in there, do not write code, just return the findings, because we know that when it's going to return the actual code, that's going to cost us a lot of money. So we're specifying keep the outputs concise, basically. So that's a simple addition for pattern 2. Then pattern 3 is basically if you're going to use it, you can use it with loop engineering with a specific goal. So if you're going to use it for planning, like we did in pattern 1, then I'd highly recommend using it in the following way. Now, Fable is built for long, one-shot, asynchronous work. So it has a self-checking loop wired into how it operates. So it's basically able to plan, execute, and validate its own output, and then make corrections to its own output. But that loop is only going to work if you frame the job properly. So if you give it enough context, including some validation criteria to go with it. So I want to quickly show you a demo of the kind of tasks that it would be great for. So it's great for things like coding, but also great for tasks where that success criteria is properly defined without a specific route on how to get there. So we've got, for example, accounting reconciliation, right? So we've entered a goal, reconcile every Q2 receipt in our /receipts folder against a bank export. The success criteria we specified, every bank transaction matched a receipt or listed in unmatched.md with your best guess at why it's unmatched. Totals should all agree. Anything uncertain is flagged and not assumed. And then we've got a verification criteria too. Sum the matched receipt, sum the bank export, compare, confirm every bank line appears exactly once. 15 lines, super simple, very checkable, and not prescriptive. This is the important part we're trying to emphasize here, because there's a fair question, which is why point the most expensive model at something as simple as expensive? But when you think about the actual task at hand here, there are actually thousands of transactions potentially here with small judgment calls that it needs to make around certain criteria. For example, we have a receipt from Uber, but the bank line says Uber asterisk trip or something like that. And then a couple of days later, there's an additional transaction because we've decided to give the Uber driver a tip. There's 2 coffees that we bought on the same day. There's lots of different nuances, right, that you'd have to consider here and prescribe. Now, we've already said that Fable is excellent in its reasoning. And therefore, if we give it a simple goal like this with verification criteria, it can actually do the thinking to resolve all those hundreds of ambiguities on its own. And this is where Anthropic say the model actually thrives. So what we're able to do is basically give it a goal, give it success criteria, and let it run, let it plan, let it execute, let it review its own work. And of course, we can change the execution and actually get it to create the success criteria and get a lower tier model like in our scenario 1 to actually execute on that. Now compare that to something, if you were going to run this inside Sonnet, you'd probably have something that looked a little bit like this. So we have the same goal in here, and you might have done this in the past with older models, right? When you're trying to actually write out a prompt for those older models, you had to be really, really prescriptive around certain things, or it didn't understand the ambiguities here. Match on amount first, then date within a 4-day window. Amounts within 15% count as a match only if the merchant also matches. We've got the Uber asterisk trip versus the Uber, etc., etc., etc. You can see this is just a small sample of the prescribed criteria that we might add over time to this. And we have the success criteria and the verification criteria as well. So we'd have to do all the thinking for these ambiguities inside these matching rules. And the ones we've got so far probably wouldn't even cover the surface on how many ambiguities and edge cases there are in something as complex as account reconciliation versus giving a more powerful model a goal, success criteria, and a way to verify it, and then telling it to flag anything that it's unsure about. So this again brings us cost versus time for something like Fable. Now quickly, when not to use Fable, the rules generally say don't chat with Fable. So like you're doing 30 minutes back and forth, it's going to cost $2 to $3, whereas a conversation with Sonnet, which is intelligent enough to chat back and forth with, is going to basically be around 15 cents. So now you know the cases in which you'd use it. Let's make sure everything else in your setup isn't forcing you to overpay when you do actually want to use it. So we're going to run through quick tips that are super easy to implement and will save you loads of money in the long run. Now, the first one is just changing the default model to Sonnet. So hit /model, jump down to Sonnet 5 or Sonnet 6, and change that as your default for new sessions. Now, teams that made this one change apparently cut their bills by roughly half with no quality loss on everyday tasks. So that's how important this simple change is. And then you can obviously switch it up for harder tasks. Now, this next one's caught me out in the past. Sub-agents actually inherit the parent model by default. So say we spin out a sub-agent here, it will inherit Sonnet 5 as its model. But imagine you're on Fable, you're doing a hard task, and Claude spins up 5 parallel research agents all running in Fable. Some of them are reading files, writing logs, and using thinking tokens. So what you can actually do to fix this is go to your .claude folder on your home user. So you can hit Command Shift and G to open this window and search for .claude. Now you're going to open your settings.json file, and then inside an env section, you're going to add Claude Code sub-agent model, and then you can specify something like Haiku. So every agent you now spin off will now by default run on Haiku. So it doesn't matter if you're working in Fable 5, your sub-agents will still work in Haiku. And Haiku is about a fifth of Sonnet's price and a fraction of Fable's. And remember, when we're spinning off these sub-agents, these workers, they just need to execute on a plan. As long as we've done the thinking upfront and the reasoning upfront to plan it in thorough detail, you can use these cheaper models. Now, the next one is that every line in your Claude.md is obviously loading at session start and going to come along with every single message that you send in a session. So per word, it's the most expensive file in your project. And the question that you need to ask yourself is, can Claude infer any of the rules that you've written in there from reading the code base? If it can, then those can be entirely cut. Now, someone actually tested this comparing a 3,847 token Claude.md with a 312 token version, which stripped to only what Claude could not infer from the code itself. And there was basically a 92% context reduction with no quality regression found. When you consider that financially, if it's a $500 a month API spend, you would save $460 of that per month. Now, as well as the obvious of taking down and reducing the number of lines inside your Claude.md, is something that I'm really guilty of too and need to actually strip out my either agents.md or Claude.md. There are a couple of things you can do that actually do not count towards tokens. You can add HTML comments in line to basically use them for teammate notes and rationale that Claude doesn't need to load into its context. So that's a really useful way to visually split up your Claude.md. And then you should also know that when you import any information into that file, so you have an @ which points at another file. So like we have inside our Claude.md here, we have an @agents.md which imports all the information directly from agents.md every single time. So the suggestion here is try and get it under 200 lines. And if you can, even slimmer, get it down to 60 lines, but anything that Claude cannot infer from the code is the only stuff that should be inside the Claude.md there. So once you slim down your Claude.md, we can also stop Claude as it's actively being used from blocking any what what we call junk reads, I guess, reading things that are purely just a massive amounts of context that don't need to be read into context. Things like node modules, any build outputs, basically a lot of what's generated doesn't need to be read back into the context, right? So we can do this in two ways, and you kind of want both to work together because they do different things. So layer one is a Claude ignore file. So in the root directory, we're going to create a .claude ignore, and inside I'm just going to paste examples of what you might ignore: node modules, dist, build, coverage, lock files, vendor, and it doesn't really matter if you don't understand exactly what these do. The importance is they contain a lot of characters that often don't need to be read into context, and therefore with a .claude ignore, they won't be read into that context. Now it's important to know that this is advisory, a .claude ignore, so it might actually still read it in. So we've got layer two then, which is actually setting permissions, which are not advisory, they're enforced. So Claude cannot read these even if it decides it wants to. So inside our settings.json, this can either be locally or globally across all your repositories. Inside the permissions, we're going to add these lines, which are denying the read of node modules, dist, and lock, and you can add more too. And then if you check all this into GitHub as well, then your whole team can get the same rules. So you end up reducing context over everybody's usage. And measured results, this is from Firecrawl's blog, show an 85.5% context reduction from just using that .claude ignore file alone. So how important might that be for your long-term context and token savings? And then you saw at the start, every MCP server that you've connected loads its full tool schema at the session start. So whether you use that MCP in that session or not, it's loading that full schema. So that's 10 to 20,000 tokens per server that's pushed in that first message and then cached and continues to go inside the context of every single message. The more MCP servers you've got connected, the more schemas you're loading in every single time. And if I run context again, you'll see that we've got the Canva, the Gmail, the Google Calendar, the Google Drive, the Notion, the Claude and Chrome MCP servers all loading in at once. And then I run usage again, and I see that Claude and Chrome is using nearly 50% of my MCP server schema space for all the token limits that are being loaded in. So if you've got even just 4 or 5 servers connected, that can be like 50 to 70,000 tokens of overhead before you've even done anything. So I'd highly recommend disconnecting anything you haven't used in the last couple of weeks. So for me, that'll be my Notion MCP. There's no point me having this. I have been using Claude and Chrome, but I so irregularly use Canva and Notion that I'm actually going to go and remove those. And I can just ask Claude to do that directly. So remove Notion and Canva MCP connections completely, because you can basically reconnect any of those in like a minute when you actually need it. Or you can actually instead just use a command line interface instead, a CLI tool, which means you don't load any schemas in. And if it's the odd call you're doing, then that will just suffice. And MCP is only good because it shows you a list of functions you can actually take actions with. So it's only important if you're doing a lot of things with a certain service and frequently. Or we can actually type in /MCP. And it's even told me I've not authenticated with Canva or Google Calendar in the first place. So we can go through and just disable them directly inside here. And now I load the same context command, and you can see I've just got Google Drive and Claude and Chrome here instead. And there's also one extra trick you can use. So inside your settings.json file, inside the environment variables, you can add enable tool search. You can add enable tool search true. And what that means is tool definitions will now only load on demand when Claude actually reaches one, instead of all of them staying in the context. Now, the second to last one is all about capturing memory on your behalf. So this only counts if you've already got your own memory system up and running. You can basically run the command /memory and turn this auto memory off. And what this enables is the fact that when you actually have a conversation with Claude, not many people know that Claude Code is actually forking that entire context into a separate background call to go and extract memories about your project. So you're paying a full input price for that context to be sent off and actually loaded into that auto memory. So by running /memory, you can come in here and you can actually toggle auto memory off. But I'd only recommend this if you've got your own memory system actually working in the background, so that we don't double up on the work and the tokens required here. And then the last one, and it's basically an account level safety net, will help just save you just in case something actually goes wrong and your team end up spending way more credits than you think they're going to do. So if you go into the Claude.ai web interface and you go into your settings and you go into usage, then if you've got usage credits turned on, you can actually set a monthly spend limit and you can adjust your limit directly for that, or buy usage credits upfront. So setting this monthly cap is that hard ceiling that Claude cannot betray, and therefore will stop you having one of those disaster moments. So I highly recommend just going in here. If you're using Fable a lot, make sure that you're not going to get an outstanding bill at the end of the month for thousands of dollars. So let's cut back to typing in context then, now that we've understood all the different tips. So let's type in hi again. And after that runs, we will run context. Now that we've understood and implemented all the tips, we can see, ironically, that we've actually increased the number of tokens. But the important thing to mention here is we're actually using Sonnet 5 instead. So there must be something still in memory that's actually increased the use of the tokens, which of course makes me look like quite a fool here. But I assure you that all the methods that you've implemented today will reduce in the long term the number of tokens that you actually use. And especially if you go to use something like Fable 5, you want to be really selective with how you actually use it. So we talked a little bit about the context in which you might use Fable 5, those 3 different patterns that you identify that you would use them in, and also ways to mitigate the token usage should you actually want to use it through different environment settings, through removal of MCPs, cleanup of your Claude.md, and all of that kind of stuff. So although we've used a slightly higher amount of context tokens here, I'm confident that going forwards, I will have reduced the number of tokens per turn per session that I'm actually using. And if you've got nothing else out of this, you've at least switched to a lower default model that's going to cost you less. Now, if you enjoyed this video and want to check out more, then check out the Agentic Academy in the description below. We've just completely revamped our entire Claude Code from zero course, and you can install an agentic operating system with a one-line install that does a lot of this for you, bakes in 40 plus skills, and also a brand new memory system that remembers every single conversation you had. And if you want to see more about that, watch the next video.